Welcome to this video on weathering and weathering processes. The learning targets for this video are: I will be able to recognize and illustrate the rock cycle, or at least this weathering portion of it. I will be able to describe the processes of weathering, and I will be able to compare and contrast the processes of mechanical and chemical weathering. So here we go. All materials are susceptible to weathering, and the rates that those materials weather and the processes depend on the characteristics of that individual material and the conditions that they're in, so the environmental conditions. Mechanical weathering and chemical weathering processes are acting simultaneously on materials. And here in this picture, you can see a concrete sidewalk that's had rain dripping on it from a leaky gutter, and you can see that it's worn away the concrete. So there's an example of some weathering taking place. The basic definition of weathering is that it's in place or in situ breakdown of earth materials, where erosion is the movement of those earth materials by ice or water or wind, and mass wasting is the movement of the earth materials downslope under the influence of gravity. So let's start out with mechanical weathering here. Mechanical weathering breaks materials into smaller pieces, and as it does that, it does not change the composition, but it does increase the surface area. Now, increasing the surface area allows for more chemical weathering to take place because there's a larger surface for that chemical weathering to attack. So you can see in the picture here, you have that same size cube of granite that has been broken down from a single cube into 8 cubes and then into 64 cubes. And you can see the corresponding increase in surface area that would allow chemical weathering to take place after that mechanical weathering had taken place. So let's look at different types of mechanical weathering now. The first one is frost wedging. Now, frost wedging is common in areas where there is a freeze-thaw cycle. And it happens because ice is less dense than water, meaning it occupies a larger volume than water. So when water seeps into a crack and freezes, it expands, which opens up that crack. And over time, it can cause the material to fail, which may cause it to fall downslope. And at the bottom of the slope in this picture, you can see the material that's accumulated from frost wedging higher up on the hill, and that accumulation is called a talus slope. Another type of mechanical weathering happens typically on granite surfaces, and it's sheeting or exfoliation. Now, sheeting or exfoliation takes place because the granite, when it's formed as an intrusion, has pressure on it that is equal in sides from top and bottom and sides to the pressure that the granite is exerting back out. But when erosion occurs, exposing that granite at the surface, you have pressure being put on the granite just from below and from the sides, but there's no longer a balanced pressure. So that granite can actually start to expand upward a little bit when the overlying rock material is removed. And as it does, it tends to crack or break off in sheets, those nice flat sheets. So in the bottom two pictures, you can see a typical scene on the left from the Sierra, probably someplace in Yosemite, and on the right of granite being sheeted or exfoliated. Salt crystal growth is typical of areas that are coastlines near a salty body of water. And this happens when salty water creeps into the permeable areas of that exposed limestone or sandstone, whatever that rock might be. The water then evaporates and leaves behind salt crystals, which as they grow will pry open those spaces and then leave that honeycomb-like appearance on the surface. Biological activity. Typically, we see things like tree roots in urban areas or suburban areas that have pried up a sidewalk and are breaking that up, or tree roots that have even grown through some natural rock surface. But it also includes things like burrowing animals or lichens and mosses that are starting to break apart the surface. And remember that biological activity does include activity that human beings cause. Moving on to chemical weathering. Chemical weathering contributes back to mechanical weathering by weakening some of those outer portions of some rocks. And chemical weathering also produces new materials. And here you can see an example of the Statue of Liberty today, with its beautiful green patina on the copper and a artist's rendition on the right side of how it might have looked before that oxidation had occurred. So when we think about chemical weathering, we should think first about the role of water. Water is the primary agent of chemical weathering, and that is in part because water is a polar molecule, which allows it to dissolve materials. And in this example, you can see that sodium chloride, or salt, is being dissolved by water. And you see that the sodium, which are the positively charged particles, are being attracted to the negatively charged oxygens in the water. And the negatively charged chlorines, represented by the green balls here, are being attracted by the positively charged hydrogens, which are the white in this diagram. In addition, chemical weathering includes hydrolysis. So hydro meaning water, the lysis meaning loosening. And what we find, particularly in feldspars from, say, a granite, is that those feldspars are attacked by water, and hydrolysis takes place, which changes the feldspar material into clay. So typically, you see from the weathered products of a granite, you see quartz breaking down into smaller pieces through mechanical weathering, and the feldspars in the granite breaking down into clay. Oxidation is another type of chemical weathering, and oxidation is basically rust, yes, being attacked by oxygen. So you see lots of examples here of oxidation of different types of materials. Very common for us to recognize things like the red color in soils or in rocks being iron rusting or iron oxide. Now, acid rain is a particular problem, and we can see two diagrams here that show the impact of acid rain on forests and on soils. So on the left side of this diagram, you see around 1880 or before typical precipitation values of someplace just under 6. And on the right side of the diagram, you see some typical precipitation pHs of somewhere between 4 or 5. That has an impact on the trees themselves, causing lack of foliation, lack of seeds to be produced. But it also has the effect on the soils below, where you're leaching larger amounts of minerals out of the soils because of that acidic precipitation. So that's another form of chemical weathering. Great. Well, you can look back over the learning targets here to recognize and illustrate weathering's role in the rock cycle, to describe the processes of weathering, and to compare and contrast the processes of mechanical and chemical weathering. I think you're ready for your Mastery Check quiz. See you in class.